that, will it? Oh. That is 2, but when you distribute this one, it becomes 4. It's 2 times 8, or 16. All right. So 16 meters away. So this happens at 16 meters. And at what time? So now we're going to plug into this equation. And so T prime. So the time from the pole's point of view, it better happen after time 0 because, not necessarily, never mind. Time is equal to 2 gamma, and then T, which was 7.7 nanoseconds, so 7.7 times 10 to the negative 9, minus X, which was 10, V, which is 0.866 C over C squared. I will say it has to happen after negative 28.9 nanoseconds because it doesn't make sense that the pole would crash into the door that's not closed yet. That's the only thing that we can guarantee. That's it, cancels out with one of those. What do we got? Digit mounts. Ball's rolling. Get more bets.
I got negative 1.23 times 10 to the negative 8. I don't know if I did that.
That doesn't sound right.
I think I did it wrong too, because I got negative 1.3 times 10 to the negative 8.
That would make more sense. Negative 13 nanoseconds. Anyone else get? With Gina's answer, the pole smashed through the right door before the right door closed. So that's why that one doesn't sound right. The other one, at least, the door is closed by the time the pole hits it. Do we have another answer for this over here? Negative 13 nanoseconds is the one on the table.
I keep getting -4, so I'm just gonna assume that's right.
times 10 to the negative.
8.
That's what I keep getting to. Alright, did that.
Well, we'll leave it as an exercise. The negative 13 nanoseconds, again, makes sense. Let's take a look at this from another point of view. Classic Cartesian space here, except this is the position axis, that's the time axis. You multiply times c for unit reasons. So if I have an event that happens here at this position and at this time, if I have a reference frame that's traveling faster, getting close to the speed of light, what that ends up doing is basically taking these axes here and bending them like that. So this could be the Barnes point of view, and then, because the pole is traveling at 0.866 times the speed of light, that's sort of the pole's point of view. And if you think about axes here, let's go ahead and extend this. Typically, if I want to figure out a particular time of this location, I just move parallel to the x-axis and see where I hit the CT axis, the vertical axis. Or if I want to know the position, I just travel parallel to this axis. Now, typically, we think we travel left or right or up or down, but you're really traveling parallel to the other axis. So if I want to figure out at what time, what position this is in the prime frame, well, I just travel parallel to the other axis, and I see where it hits. If I want to know what time it is, then I travel parallel to this axis and see where it hits. And so this would be CT1 prime, and this would be X1 prime. And so we get this distortion here. First off, this event happens before time is equal to 0, which happens here. And then that gets distorted as well. So anyway, I think that's where we'll end it. So much more cool stuff with relativity, and then you get into quantum, which basically teaches you to question everything you ever learned in any class you've ever had. Quantum basically says that other than going faster than the speed of light, well, if you start out slower than the speed of light, you will never get to the speed of light or go faster, but everything else is in question. With quantum, I can mysteriously, suddenly, teleport to my office. There's a non-zero probability that I can do this. And there's one piece of equipment that we use called a scanning electron microscope, which exploits that. But that will be for another lifetime.
I have a question about the test on Thursday.
Oh, okay. You could have asked them earlier, too.
Oh. Hypothetically speaking, worst case scenario, if we do, or if I do terrible on the
Okay.
test, how much will that affect my overall grade?
Um,
I'm nervous about that.
All right, so there's 4 test grades. So one test, so your test grade is either going to be 40% or 60% of your overall grade, depending upon the quiz and lab grades. So that test is either worth 10% of your grade or 15% of your grade.
Okay. And,
But the system is designed to have a little bit, to have some shock proof to it.
okay,
So if you've done well all along and you just bombed this one test, it shouldn't affect you too greatly.
okay,
If you were borderline before, you probably won't be borderline anymore.
okay. And you said 28 was up for grabs on the test, right, like
It is fair game.
fair game?
You know, if you look at the old tests, I never get too complicated, other than the Sue and Lou getting back to their same age, but that's usually like part D, so it's not a huge impact.
And, will you post the answers to MasterSet 28?
Yes,
Okay.
if I will try to remember when I get back to my office.
Okay.
Says chapter 20, 23, 28.
The
last test.
the last test. 22, 23, 24, 28. 24 is, when we derive the speed of light, that officially is chapter 24. But the bulk of it is 22, 23, 28. Actually, the bulk of it is gonna be 22, 23. Well, it makes sense, I got 3 chapters, even if I split it evenly, that's 2/3 of the test right there. All right, I see looks of excitement and sadness at the same time, because Thursday's our last day. I'm accepting stuff through Friday, unless I make some special arrangement with you, but of course, the semester officially ends on Friday at midnight.